Hi guys. Okay, so if you're watching this video, it means that you already turned in all your work, but you tore out the pages for lesson 27 because you are amazing and you want to finish learning all the fourth grade math before you get to fifth grade. So I think that is fantastic and I applaud you. I'm very proud of you. You're the best. Because everybody else turned in a workbook without this lesson completed, probably. Or they just kind of guessed how to do it. So this is the very last fourth grade lesson. It is lesson 27. This is session 1, and it starts on page 555, 555. And we are comparing decimals. Okay, it's 4 sessions, so there will be 4 videos. And you're just comparing decimals. So if they give you 2 different decimals, you just have to decide which is the greater decimal, okay? Just like regular comparing numbers. If it was 710 and 714, okay? If we had to compare those, we would use symbols like less than, greater than, or equal to decide which one is greater. Remember, it always eats the larger number. The alligator mouth eats the larger number of the 2. So that would be 710 is less than 714. Okay, comparing regular numbers, not decimals, comparing numbers was like our second math lesson of 4th grade. So now we're kind of ending the year, circling back, but now we're doing it with a harder number. We're doing it with decimals, okay? So this is the family letter for the lesson. If you want to tear this out, it kind of just explains on one page how to do it all, okay? So one strategy that would be time consuming is drawing a model for the fraction, or for the decimals, sorry. Decimals, not fractions. So this one shows 65 hundredths, and this one shows 7 tenths. So which is greater between those two? It's kind of tricky, especially because when they have, see there's 2 place values, so tenths and hundredths, and then this one is just tenths, because 65 is greater than just 7, right? But it's 7 tenths, which is equal to 70 hundredths. So 70 is greater than 65. And that's what they show down here with the place value chart. 7 tenths equals 70 hundredths. So really it's 70 hundredths. So 7 tenths is greater than 65 hundredths. So this is actually the greater one. Kind of tricky, but we'll get through it. So that's just the front of the family letter. On the back is an activity. If you would like to do that, you have to go to a store, like a grocery store or hardware store or something, and complete that activity. If you want to do that, go for it. Session 1 begins on page 557. Okay, we're centered, we're in. All right, so we've got a try it problem that we're going to read and solve together. If you want to try it on your own first, you can. All right, Keely and Casey each buy equal-sized bottles of water. They each drink some of their water. Keely now has 5 tenths of his bottle left, and Casey has 4 tenths of her bottle left. Who has more water left? Okay, so let's organize some information. Keely has 5 tenths of the bottle left. Casey has 4 tenths of the bottle left. And it's asking who has more water left. So which one of those is greater? So 5 tenths as a fraction is 5 tenths. Okay, and 4 tenths as a fraction is 4 tenths. So now I can compare those two. 5 tenths, oh geez, 5 tenths, not 5 fourths. 5 tenths and 4 tenths. Comparing fractions was a few lessons ago. Well, it was like lesson 18, I think. We did it in school together before school closed, so it was a while ago. But if you have 2 models, those were supposed to be squares, interesting. Okay, and I split them up into equal parts, 10 equal parts because it's tenths. those are straight lines. Look at me go. I was gonna say it's because I've had a lot of coffee today, but that probably makes my hands shake more, so. Okay, whoop. All right, 5/10 and 4/10. If we're comparing them as decimals or as fractions, 5/10 would be 5 equal pieces colored in. So half of it, and this one would be 4 equal pieces shaded. It's kind of hard to see the difference, but if you count the parts, obviously 5/10 is greater than 4/10, right? And we probably just know that looking at our fractions. You don't have to draw the models if you can see that 5/10 is greater than 4/10. So who has more water? Keely with 5/10 or Casey with 4/10? That would be Keely. So Keely has more water left because 5/10 is greater than 4/10. And that's it. So you can show your work with models like that. You can convert them to fractions and show it like this. You could also do it with a place value chart. That's how we did it a lot when we were just comparing numbers at the very beginning of 4th grade. Ones, decimal point, tenths, hundredths. Okay, and it has 2 rows because there's 2 numbers, 5/10 and 4/10. So 0 and 5/10, nothing in the hundredths, and 0 and 4/10, nothing in the hundredths. So remember, we look by place value. We start over here furthest to the left and look over this way. So there's the same for the ones place, so we can't tell yet. And then for tenths, what's the greater digit, 5 or 4? 5 is greater than 4, so this 5/10 is greater than 4/10. Remember, you just look down, look across starting at the ones place and go over. Okay, pause if you need any of those strategies to copy down. We gotta look at the models on the next page. Oh, no, we don't. Okay, usually they show us a couple models, but I showed you all of them, all the various ways on the previous page, so that's okay. Number 1, does Keely or Casey have more water left? Explain how you know. Okay, so it's basically just exactly what we wrote down for our answer. Can I zoom in a little? Okay, who has more water left? Keely has more, and it says explain how you know, because 5/10 is greater than 4/10. 5/10 is greater than 4/10. So there's 2 reasons why I know that. Well, it's the same, right? 5/10 is greater than 4/10. 5/10 is greater than 4/10. Okay. Number 2, you compare the decimals 5/10 and 4/10 to decide who has more water left. Suppose you have 2 more same-size water bottles. One bottle is 8/10 full of water, and the other bottle is 9/10 full of water. Compare them to show who has more water, write them in the place value chart. So 0 and 8/10, and then 0 and 9/10. Okay, so you compare them from left to right. So starting at ones, just like whole numbers, there's 0 and 0, so we can't tell yet. So we move over to the next place value, tenths. What's bigger, 8 or 9? 9. 9 is greater than 8, so 9/10 is greater than 8/10. That's it. C, which has more water? The bottle that is 8/10 full of water or the bottle that is 9/10 full of water? Well, 9/10 is greater than 8/10, so the bottle that is 9/10 full has more water. Okay. Number 3, reflect on the bottom. It's not the normal reflect question where it talks about strategies. It is different, and it's thinking back to fractions, comparing fractions. Okay, so think back to lesson 18. Suppose the water bottles are different sizes. Could you compare the bottle that is 8/10 full and the bottle that is 9/10 full in the same way as in problem 2? Explain. So these are 2 bottles. See how they're different sizes? This one is tall, this one is shorter. Different size bottles. So if this one was 8/10 full and this one was 9/10 full, would the 9/10 still be greater than the 8/10 here? Probably not, because remember, you cannot compare if they are different sizes. Since they're different sizes, you can't compare them the same way, okay? Just like we can't compare fractions if the whole is not the same size. Like if I ate a large pizza, or if I ate half of a large pizza and my cat ate half of a small pizza, we didn't eat the same size, right? Because even though it was half and half, they're different size wholes, so I can't compare them. Okay, so no, because the bottles are different sizes. Okay. Pause there if you need it. Practice page on page 559. Our green pages. In the middle of our little bubble web map thing is compare decimals. So that's what our whole lesson is about. And it just has examples all the way around. So let's just show some different ways we could do that. Maybe I'll just explain in words what it is first. So I can say, tell which decimal is greater. Or greater, less, or equal. So that's what we're doing when we're comparing decimals. I could draw a place value chart. This will be ones, decimal point, tenths, hundredths. Oops, just shortening everything. So 0 and 31 hundredths, 0 and 35 hundredths. Okay, so I look at my ones place, 0 and 0 doesn't help me. Look at my tenths place, 3 and 3, not helpful, they're the same still. If I look at my hundredths place though, 1 and 5 are different. 5 is greater, so that means 35 hundredths is greater than 31 hundredths. 31 hundredths is less than 35 hundredths. Okay, and then I can just draw some more examples, or write some more examples. 8/10 is greater than 7/10. 8/10 is less than 9/10. I could convert some stuff to fractions first, so 3/10 equals 3/10. 2/10 equals 2/10. 3/10 is greater than 2/10. Cool, I could draw a model. Let's do, I guess I have to do tenths, don't I? Because I'm doing decimals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Where'd my highlighter go? There we go. So let's just color in a bunch. 8, and let's just do like 2. so this shows 8/10. This shows 2/10. Which one's greater? Well, 8 is greater than 2 in the tens place, so 8/10 is greater than 2/10. Okay. I don't know how else to show it. That's like everything. Place value chart, models, convert them to fractions, and compare the fractions. This is just comparing them without any strategies. Let's just call it good. Okay, number 2. Compare the decimals 4/10 and 5/10. Write both decimals in the place value chart, then write the symbols to compare. So 4/10 is 0 and 4/10, 0 and 5/10. That's all we do for the place value chart. So to compare them, the ones place doesn't help me. I have to look at the tenths place. What's bigger, 4 or 5? 4 is less than 5, so 4/10 is less than 5/10. Oops, cut off a little, sorry. Okay, pause there on this page if you need to catch up with any of the examples in the bubble map, or number 2 down here. We should have one more problem left. Page 560. There we go. Okay, number 3. Raphael and Zena each buy equal-sized granola bars. They each eat some of their granola bar. Raphael now has 6/10 of his granola bar left. Zena has 7/10 of her granola bar left. Who has more of their granola bar left? Okay, so you could draw a model for each. I can turn them into little fraction models. It has to be tenths. Half, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I'm going to do R for Raphael, Z for Zena, and Raphael has 6/10 of his granola bar left. 6/10. Zena has 7/10 of her granola bar left, according to the problem. So I'm going to color in how much they have left of their granola bar. He has 6, 2, 3, 4, 5, 6. She has 7/10. 1, 2, 3, 4, 5, 6, 7. So who has more? Zena has more. 7 is greater than 6. I could do it in a place value chart. Ones place, decimal point, tenths, hundredths, 0 and 6/10, 0 and 7/10. Ones place doesn't help me, decimal point doesn't help me. Tenths. In this place value, they are different numbers, and 7 is bigger than 6. So 6/10 is less than 7/10. So Zena has more. Zena has more left. I'll just leave it there. Okay, how else could I check my answer? How about I convert them to fractions? So Raphael was 6/10, and that equals 6/10 as a fraction. And Zena was 7/10 of her granola bar left. Bless you. My dog just sneezed. And that as a fraction is 7/10. I could compare those fractions. 6/10 and 7/10. The symbol I put in between is less than. 6/10 is less than 7/10. Check. That's what I got up here. All right, and that's it for session 1. See you in the next video for session 2. Goodbye to all 2 of you that are probably watching this.